recording this session, and then we can post it on YouTube and have people watch it afterwards if they're interested. So welcome to the launch event of our partnership between LangOptima and Lead Semantics, and we have the two founders here, myself, Edwin, and Prasad, who will give the floor in a second here also. But just to give you a little bit of an overview of the agenda for today, we will just talk a little bit about each of the companies and the partnership story, just for a few minutes. But the heart of the webinar today will be about knowledge graphs, as well as all of its value and its intricacies and such, as well as its implementation as KGMT, or Knowledge Graph Mediated Translation, that we've worked on very diligently and have put in production very effectively, and we'll talk about that use case. We'll also talk about NLQS a little bit, and we'll explain more about that, which is natural language query search on SQL databases. We'll spend a few minutes on that also, but we'll also have questions and answers for you also. So it looks like you can chat to us, and I don't think it's seen by everybody, so feel free to chat to us, and then we can just answer that. And we can also give you allowance to talk on the webinar if you're interested in that. So just let us know if you don't mind coming on, and then we can give you access to that. So okay, so I'm Edwin Trebels. I'm the founder of LangOptima. We started earlier this year, and we essentially are all about helping other companies grow. And the way that we do that is through marketing and also language operations, which includes knowledge graphs, very much so. And then which is of course where Prasad comes in with Lead Semantics. But we also have other offerings through custom software development through another strategic partner. But we essentially help other companies grow at LangOptima. And I'm Edwin. I've been in the industry for 22 years now, and working on all kinds of various verticals, very interesting, all kinds of different stories to tell, as you might imagine. But that's me. That's enough about me. So Prasad, how about you explain a little bit more about yourself, and maybe also start with Lead Semantics also included.
Well, that was not really enough about you. When maybe there will be a separate occasion to bring all those good things that you are for. But thank you very much. And I like your initial, invite to the folks participating to join in effect, put us on the spot if they want to. So for all the claims that we might be going through here, right? And so. Well, about myself and Lead Semantics, I am formally trained in computer science, theoretical computer science at that. A lot of time spent in computational linguistics and knowledge representation and neural networks and all this AI stuff. I had spent about more than 2 decades in semantic technology, so-called symbolic AI, different than the statistical AI. But I mean, it is the other side of AI, which without is not complete, is our thesis, and it's proving to be that. That you need generative AI together with symbolic AI to complete an enterprise level AI solutions. Which is what some of our partnership focuses are. So we developed. I founded this company, Lead Semantics. With that in mind, trying to bring this hybrid AI to the market, and we in that process created a product called Text Distill, which is our flagship product. That is primarily it transforms your multi-modal content, text, video, audio, and image into an executable knowledge. A structured knowledge at that. So we call that semantic knowledge graphs. So this automatically creates that, and we'll have a chance to talk about that a little more. That is incidentally the cornerstone of our partnership here, knowledge graphs, and how we automatically create these knowledge graphs from your content. So Lead Semantics itself is in the US and in the East Coast. And the partnership is very exciting for us in terms of bringing in this, very timely, very rigorous, and and mature technology, the knowledge graphs, to the language industry. And so we see a big opening here. Clearly, language industry has the most exciting content. So much of it is language alone, and all the other communications in the form of media is also part of it. And then the knowledge graphs are the ideal artifact to capture it all. So the human knowledge is preserved to guide the subsequent, whatever the computation that you might plan for in terms of applications, translation being one of them. So
That's great. So
back to
yeah, so I had an issue when I was on client side, and it was, how do we improve our machine translation for long form content? In addition to the fact that it was long form, we also had a very high quantity of domain specific concepts. So as we figure out later, was that normally you would have maybe 20, 25 high level concepts in most domains, but then we ended up having some 100 or so of those. So it became very complicated, and which is why our machine translation really was only like a 50-50 chance of getting it right, if not lower than that. So it was not very good machine translation. So we were trying to figure out a way to help our processes. We had a limited base of volunteers that could work on that content. So we really needed to find a way to be more effective and efficient. And really, that's how I came across Prasad and knowledge graphs. And also found out that there's many other use cases for knowledge graphs, and we can speak to that in a little bit later as well. But machine translation improvement was one of those problems that we faced. So that's how I found Prasad, and reached out to him, and found out that Prasad is very well experienced in the field of knowledge, as he just mentioned. Also, a triple decade veteran nearly, and just wonderful to talk to, and very generous with his knowledge. So I'm glad that we can present this shared vision and knowledge to you today. So that's essentially why we are collaborating. We're hoping to do, we were hoping to really assist with creating the very best and most accurate output from machine translation. But it's not just machine translation, because really knowledge graphs become the source of truth for all AI applications, to make them accurate, and to make them have less, as they call, hallucinations, if any actually, because in a lot of cases they would be reduced to zero or near zero. So that's the power of knowledge graphs, and not just knowledge graphs, but in theory, even knowledge graphs within knowledge graphs. As I'm learning more about, you can just get deeper and deeper into the subject, and then constantly create these wonderful levers of quality. So that's really what we've been working on since November already, and quite in depth actually. We've been working on it almost every day. We've met and worked on this, and it's been really exciting, and great results, which we'll show you later. Prasad, do you want to speak to that also?
I will add to some of the good points that you raised. The particular use case you and I had worked on together, which is the religious and theological text that you all have, which, as you rightly pointed out, it's a lot different than the transactional, business-oriented, texts and the literature, or the language that we see elsewhere in rest of the business verticals. The big contrast is that the typical business language, the number of concepts are fairly, they all fall into predictable, concept hierarchies, versus the theology, as you would know more than anybody. And I'm more of a linguist in terms of the engineering side of language, as opposed to kind of the actual knowledge itself of the particular subject matter. And so, but the characteristic is that it has so many different individual concepts that the knowledge graph almost is synonymous with the ontology, the meta knowledge that drives creating these knowledge graphs. So in the computer science world, there is a clear distinction between the meta layer, where the defining structures, and then the actual instances that you see in the reality that fit into these definitions of what that ought to be. Here, it kind of collapses quite a bit, and so it really raises the bar in terms of the complexity, because obviously we are trying to automate this process. And so and that's what so we really explored a very unique charter here. And to produce a high quality translation using these knowledge graphs is very heartening and delightful at that. And then as you rightly pointed out, it really is a business use case that can be taken to uh, other industries. Every other vertical can easily leverage this.
Very good. Yeah, so let's take a step back, and maybe you can explain very briefly, what is a knowledge graph?
Okay. Yeah. So as the name suggests, and folks have come up with the name knowledge graph to mean that it is a structure of knowledge of some sort, some structure that holds knowledge. So I don't want to get too deep into the philosophical and all the aspects of representing knowledge and things like that. But at least I'll start off saying that information is a part of knowledge. So when we know bits and pieces of something that we can relate to and we understand, those are pieces of information. When multiple pieces of information about a particular subject get added on, then you have crossed a certain threshold to kind of allow you to make actions, to make sense of something more significant and things like that. That's when it starts to become knowledge. I mean, that's the an active practitioner's definition, to our engineering teams as well. Um, so from that sense, now what would be the structure of such knowledge? So by default, it ends up the best structure is a graph. Because you have concepts. Knowledge is about concepts. Instances that are available in the reality that we experience, and so these instances are all interrelated. So, and that's how the knowledge first comes about.
Okay, so so how do we do it? I can show you the picture of Texas still, but how do we make the knowledge graph, which is also visualized here on this picture?
Absolutely, absolutely. I mean, this is an apt time to kind of bring it up. So your source, where is this knowledge rooted in, right? I mean, it is rooted in some source content that you might have. It could be, as I said, it's multimodal, text being one of them. It could be media, audio, video, image, and all that. And so all of that will be pumped in through text distill. This is the framework, the pipeline framework we have within the product. It goes through various layers, but it uses an ontology. Ontology is saying that, okay, in this source, I am interested in this subject area. Now, all knowledge that is relevant to this subject area. Because, for example, if you take the text being all news, and you may not be interested in all aspects of news. News kind of spans all, probably 15 different domains. It's about current events. It's about war. It may be about trade. It may be any number of things, and you may be interested in only one subject area. And so you would configure the pipeline with that ontology of that subject area of interest. And then all of this content is filtered, if you will, for the content, the only content that fits the ontology. And then of course it kind of restructures and makes it into what these facts that are interconnected, and they end up becoming this knowledge graph. So that is automatic process. So for companies, it used to be that this was an extremely difficult process. I mean, it was like pretty seriously engineering centric, and so the subject matter experts were kind of relegated at that time. But it is not, at this point, that is not even the case. I mean, it's a lot simpler. It's very practical. And even though knowledge graphs have always known to be extremely valuable, they were put away because it was complicated and it was expensive, both of which are not true anymore. It is readily accessible, and given that it is valuable, and there is no real replacement to knowledge graphs. It's all your knowledge in a structured format. I mean, what best any other artifact that can come close to helping you, do your decision making in a transparent way. And so that is the promise of automating this pipeline with text distill, for example.
Right. So we can take, let's say, 500 pages of source knowledge, or let's say 5 times 400 words. So let's say 200,000 words of long form content or content, and then it then gets extracted into these triplets, and then, but it gets more complicated than that. But it's also wonderful because there's all kinds of assignments that we can provide to these triplets. Like, well, before we move on forward, what is a triplet? Just so that everybody's on the same page.
Right. A triple is one single fact. Like, so Edwin and Prasad are in partnership, right? In partnership is like the relationship between Edwin and Prasad, for example. That is a triple. There are two ends to this triple, and it is a fact, that you can talk about this fact, you can relate other things to this, but two entities connected through some, we call, in the technical language, it's a predicate, but it's a relationship. That's a triple. So for all the text that you are ingesting in the 500 pages you talked about, you are extracting these facts, the facts that are rooted in the content. So you can actually point back to where it came from. So it is undeniable that that's where it came from. And so they typically all these, facts, which are triples, they get interconnected according to what the narration efforts, if you will, in the content.
Right. So with TextDistill, you've created a semi-automatic process where you could take the files, extract the triples, and then you can also then insert the human curation process, where human beings can go in there and they can check the quality of this, which we've done this very thoroughly, spending nearly 1,000 hours this year on this particular domain because it was such a challenge to tackle this particular domain. That is not necessary for most domains. This is essentially the most complicated domain you could possibly tackle. So we spend a significant amount of time doing the human curation, but because we did that, because we invested that time, we were able to have unbelievably high quality output. Because it becomes a file, like you see on the picture here, nquad or JSON LB. Those are files, of course, that can be then utilized in a knowledge graph rag workflow, right?
Exactly. So this knowledge is directly driving all the prompts. I mean, you are generating, because we are in this generative AI world. In order to take advantage of generative AI, GPT-4o or even GPT-5, you can generate these prompts dynamically driven by these knowledge graphs. And so small prompts, large prompts, you can literally construct based on the context of what the knowledge graph is pointing to, and just deliver the accurate, necessary, specific context for generative AI to function and produce the right result.
Right. So again, I'll just invite everybody just to drop their questions in the chat. If you have specific questions, just put it in there, and then I'm looking at that, and I can answer those even anonymously if you prefer. So that's fine. So just don't be shy and ask questions, because in this process since November, that's all I've been doing, asking questions and learning more about this process, because it's really fascinating. Because with all of that, you end up with a knowledge graph, which is visualized in this image right here. Do you want to speak to this a little bit, Prasad, to see what we're looking at here?
Yes, so this is, the actual knowledge extracted, those triples, so-called, that you asked. So in this particular document, there are two documents that were used to, the text distill process, two documents, and there was an ontology that was fit in. I think this is crime-related ontology that we fit in, and so it picked up all the crime events and all the related, you know, important concepts, and then it created the knowledge graph. And so you have this the knowledge graph visually that text distill can show you. And then other interesting thing is that every node, which is every fact, a part of a fact, is directly connected to where it has come from in the content. And it's the same thing for even video and audio and so on. So it'll take the timestamps and from between these timestamps where this particular fact was identified and brought up. And the accuracy for text is a lot higher. I mean, it's almost as good as it can get. You want it can go up to 99, 98%. Audio and video and things like that, it depends on the vision models and the models that are they're changing on a daily basis, literally. So but the knowledge graphs literally retain all that knowledge. And now to drive your generative AI processes off of this knowledge graph, all the element of hallucination is over. We have sorted it out, put it into this very dependable artifact in the middle. In a sense, automated curations and human curations all have been put in, and you have this knowledge graphs. And using this to drive generative AI, you can imagine, the value is that much higher.
Yes. So we did get two questions already. So the first one is, can a term base be extracted into a knowledge graph?
Yes, I mean, if the term base, absolutely, like glossaries, if you will, right? I mean, terms, terminologies by themselves can be absolutely create a first layer knowledge graph, if you will. So-called, there is a wonderful standard in the knowledge graph world, um, so-called simple knowledge organization systems, SKAS, that allows you to organize all your terminologies in hierarchies and simple relationships, because at individual terms, you will hold simple relationships, and it'll without any loss of meaning. And then that will help you build a much more sophisticated or as required ontology to drive all your translation to content generation to all these extreme cases.
Great. I'll just wait with the second question because we'll get to that in a little bit later. But yeah, so with this image here, we're looking at the source text on the left side and the visualization of the knowledge graph and the connections of the triples. You can see how it essentially organically makes the knowledge graph when you connect all the triples. And then you can search it. So that's one of the side benefits of text distill, where you once you've created the knowledge graph, you can use natural language to search it, and and it'll come up with questions and answers. I mean, when you put in your questions, it'll answer just like with LLM results nowadays. So when you go to Google, you type in your question, you'll see the summary at the top. Well, this actually does exactly the same thing, but it's from the knowledge graph, so it's more accurate, and it's also your domain, and it's your corpus. So it's really great as a resource for, let's say, customer service, if they're on the phone and they need to query the data or the knowledge base, the corpus of your company. All of a sudden they can do that very quickly, and it's also up to date because it's a single source of truth, so it can constantly be kept up to date, and then it's up to date for everyone. So it's a very powerful use case aside from just machine translation. We're talking about customer service support in this case, or researchers in your company that everybody basically in your company can have access to this, and then there's a single source of truth that way for them. So it's really powerful, actually.
I'll add a couple of things here to what you said. One is that search is a very important aspect and an important application of AI in general. And the best of search so far is plain LLM. On top of that is a RAG-based LLM, so which is retrieval augmented generation. So you're kind of giving the LLM the context within your own content, if you will, your text documents and such. That is RAG, and then Graph RAG is one step above. It is a lot more, accurate, more relevant, and more comprehensive. And Knowledge Graph RAG is even one step further. Knowledge Graph to regular Graph RAG, there are serious important value adds, uh, especially when you have a large company with multiple departments and all that. There is knowledge, and you're always looking at one part of the knowledge, whereas the entire thing is one uniform knowledge that drives the company's mission and its targets and all of that. And Knowledge
Right.
Graph RAG is what comes out naturally with a system like TextDistill and a knowledge graph at the center.
And you've actually coined or popularized this term, haven't you, Prasad?
Well, I wouldn't say popularized, but at least we spoke about this at the Knowledge Graph conference in 2023. Which is 2 years. Gosh, I mean, it's when this was just coming about. I don't want to say that we were the first ones that kind of ever coined it, because we have been working with knowledge graphs for a long time. And we have, we were forced to work with generative AI, acknowledge that generative AI is another force to reckon with. And so we merged these two upfront, probably 2.5, 3 years ago. So we were one of those earlier teams. There are other teams that we know of that have worked with these two things together. So-called this hybrid AI, the neuro-symbolic AI. So TextDistill is totally rooted in that. And so we are very familiar, and we see the value of this. And as when we run into competition that doesn't talk about this, we know how much different we can be and value added we can be.
Right. So just speaking to this workflow then, so we've got our knowledge graph with a source text glossary or term-based translation memory can be incorporated. Again, human curation can be added to this process. So again, it can be automatic, but of course, to have higher quality, you need to add the human curation, and then you have a knowledge graph RAG. So not just RAG, not just graph RAG, but knowledge graph RAG implemented. Another addition is automatic post editing, and we'll get to the results in a second here. But then again, like there can be human editors and further automation within this workflow, and integration with TMS, which we'll also get to in a second. Did you want to say anything else about this slide, Prasad?
Yeah, I will stress on one thing. You covered most of it. Just one thing about the human curation part of it. Because humans are the source of all the knowledge to begin with, and so no matter the AI, humans still carry, linguists carry ton of knowledge that still, the more time they can spend at it, they will always know where to correct it. For example, in a translation situation, right? So this is this so-called creation of the knowledge graph. We can really absorb all that, successfully deploy all that knowledge. Uh, you know, so in a place where that can be automatically leveraged downstream. So the time that the linguists and the subject matter experts, their time, the valuable time is spent in creating a very valuable artifact. Otherwise, it will be random, in the overall downstream process. But now, once you have a curated intermediate artifact like a knowledge graph, the further automation that you impose, like the graph RAG and all of these other things, they all can take advantage of all the effort that was put in up front at the time when it was required. When you are transforming the source content into the computable, whatever the next artifact, which in this case is the knowledge graph.
So why can't we just use large language models alone with prompting?
You could, I mean, of course, so the claim is that, and then all these big LLM folks will kind of, point to a world where you don't need anything else and LLMs are just that. They can do everything for you. but it's very critical to realize that LLMs, the hallucinations uh, out of the LLM architecture is a hard problem. It's not even an easy thing to attempt to even. I don't even know how people can claim that that will go away. The architecture of LLM, generative AI, does not have anything else other than hallucination. The other side of hallucination is the creativity, which if some for whatever is the reason, if they are so forced to kind of deliver an LLM version into the future where there is no hallucination, then the value of LLM for which it is really useful, especially as a counterpart to other AI technologies, which is the creative aspect of it, is lost. And so there is a point at which you don't want the hallucination to go away, but you need to control it for your specific use case in your automated workflows and things like that. And that's where knowledge graphs come in. Knowledge graphs are tried and tested knowledge that is shared, and everyone has signed up for this knowledge in this particular subject area, for example, all the stakeholders. That's what is now computed, and it has an artifact.
Right. So just to be clear, knowledge graphs, it might be new to some people, but it's been implemented for a long time now. So in what settings are knowledge graphs already in place?
Oh, I mean, gosh, I mean, they've been in education, they've been in finance, they've been healthcare, quite a big areas in the media,
Right.
news, media, and so they are like it's a very rigorous technology. Only, as I was telling, it used to be very expensive until even a year and a half, 2 years ago. But generative AI has changed that. A lot of the expense part can be leveraged or can be done away with using generative AI. But the artifact, the need for an artifact like knowledge graphs doesn't go away. If anything, it has highlighted the need for it in this fast times of generative AI.
So why can't people just do it themselves? Can they do it themselves, or what is the value that we're offering to the world?
Right. Yeah. I mean, so knowledge graphs are easier to create for people, someone that has already dabbled with it in terms of, making the right choices. For example, so every knowledge, whether we plan it or not, there is an ontology, so-called the metadata or the meta schema that says, okay, these are the concepts and this is how these concepts are related in this schema or in this subject area of interest. Any other thing does not fit our requirement or our applications downstream, right? So how do we evaluate what fits our so there is a need for someone that has been at it for some time. It's not like total easy. As I said, the expense part of it has come down quite a bit, but the knowledge to create these knowledge graphs is still there. It is easy to learn, and so I see a lot of training and tutoring sessions going all around, and they have increased quite a bit over the last year and a half. We ourselves, are teaching, Edwin, you and I. Um, that's what I would say. So it's I would say for first timers, it's better to have someone that has been at it one time, so what to expect and what the short turns are, or sharp things that you will encounter and what choices to make with the technology offerings and choices that you have.
Right, because there's a lot of possibilities with knowledge graphs. So if you are capturing it possibly incorrectly, or it's not quite as efficiently as it could be, then you could be wasting a lot of time. You could, and a lot of resources, and then you find out, oh, oh boy,
Right.
we need to do this completely differently, actually, and then you have to start all over again. So that's not good, and that's why it's good to employ folks like like yourself, who have been involved with this for decades now, to figure out the best way and the most efficient way to solve it. But also, again, like text is a very powerful tool, because it can actually just extract and assist with this process semi-automatically, which saves like an unbelievable amount of time.
Right. And in most domains, the human curation part of it drastically comes down, drastically by any measure, from a philosophical, highly abstract text to like a finance or a news and things like that. It's almost near automatic. And of course, the experts of the domain, of the subject area, will spend their time in figuring out, is the ontology accurate? And ontology itself, as esoteric as it may sound, is a simple, what concepts are, and how they are related, and an organization, and there is a little bit of a science to it.
Yes. So let's go to knowledge graph mediated translation, because that's what we've developed, and it's very powerful because the results are there. And I'll share the slide that we have here, because it is really remarkable what we were able to accomplish, because we have now this is for the domain that we were just discussing. We were talking about religious text, and we're talking about a domain that essentially didn't have a lot of success with just neuro-machine translation. Even with glossary, we're only at 42% still, and that's with a common language pair from English to Spanish, and even English to French was similar, English to German also. So neural machine translation for this particular domain, because it was long form, it was there were some 100 high level concepts and such. It was only at that 42% level, even with glossary management and such. And then with knowledge graph mediated translation, now we're at the low end, at 80% and 85% with automatic post-editing. Now, automatic post-editing, the ability for automatic post-editing to be effective is reduced because we can constantly improve the knowledge graph mediated translation, which reduces the need for automatic post-editing. So in other words, we are very lean and solving it at the root in that sense. So we have a 5% incremental jump because of that. But normally automatic post-editing actually can do a lot more than that. But because knowledge graph mediated translation is so effective already, automatic post-editing is less needed. So, now that's at the low end. We're also seeing results, and we're constantly fine-tuning all the way up to 93% accuracy at this most difficult of domains. So we're really excited because it's so accurate for such a difficult domain, which then also makes it so effective for other domains that have a lot less domain-specific concepts. Do you want to speak to this a bit more, Prasad?
Yeah. So, I mean, the clear, I would try to get into, why a knowledge graph guided translation can be better. I mean, folks can easily relate to, because using LLMs to translation for translation issues is pretty much prevalent everywhere right now. And the big difference that knowledge graphs bring to table with this is that it brings the narrative context as the translation is required to be done, at certain parts of the text. It is bringing the relevant context, because the knowledge graph has the sequence and the discourse level elements and whatever that we can instrument. And as you rightly pointed out, so much of it, the quality aspect can be achieved by tweaking things within the knowledge graph itself, because it has plenty of room to kind of accommodate brand related voices to in this case the actual the source text, being that it is abstract. I mean, all these concepts that we have, the knowledge of all these concepts, if a very esoteric concept, if it appears in a text, already the context is kind of modified. It's like it has added a different color to that context. And so we can bring in those elements that we think are important, that should be reflected in the language that is used in the translation. So plenty of room to kind of really move it along. Only the structural aspects of for post editing, like syntax and things like that, those can be left out. Those are like relatively low value to kind of take time in the knowledge graph or space in the knowledge graph. But knowledge graph can hold all of these things in a very systematic, organized way to be drawn upon exactly at the point when they are required in your translation.
Yeah, because a lot of times vendors will not speak towards the quality of their AI solutions, and I've been on a mission for quite a long time now to be very open about about the quality and how does it work, and how accurate is it actually. Because one of the problems, of course, is that the remaining percentages, or the last mile, they are sometimes the most, or oftentimes the most important last percentages. So it's very important to get those conceptual connections accurate, which is again what we are seeing actually, that some of those most difficult questions in the machine translation quality is being answered actually correctly through this knowledge graph mediated translation. In essence, when we send an assignment to the TMS, it can create the structure of the knowledge graph, or the inside of the knowledge graph, or connect it to the knowledge graph, and then it can essentially recreate it in another language. So the meaning the meaning is there. It's actually content generation, isn't that right, Prasad? We're actually generating the content into another language.
Absolutely. I mean, you hit upon a very important concept here. Translation is like generation itself. In that sense, content generation is just another fantastic application. And knowledge graphs are multilingual. I mean, they are language agnostic. Knowledge is language agnostic. And here is an artifact, computable artifact, knowledge graph. It holds, multilingual terminologies to concepts to relationships to all of that. And so it's extremely valuable stuff to both translation as well as content generation.
Right. So it is available on Crowden at the moment, specifically as a TMS, but we are working with other, we're working towards other TMS. But essentially, just to make it very practical on how this integrates, we do actually have an app on Crowded. Text is still KGMT, which can be installed, and then Crowden actually has a special offer, which I'll just throw in here at this point in time. But if you sign up for knowledge graph creation, and then with KGMT with us, with LangOptima, then you can actually get 12 months free with Crowd on the but you need to have the knowledge graph in place, and then we can give you access to Crowden for up to 12 months. So it's quite a generous offer from Crowden, but it is they believe in this tech, and they see the value of it as really another language asset. Because just to be clear, also is that knowledge graphs can be multilingual. Isn't that right, Prasad?
Yes, they are multilingual. So absolutely right from the standard itself, because knowledge graphs are literally they are driven by W3C standards, the way all the solutions are put together, and the standards ground up, they support multilingual content.
Yep. So we have an API connection here, and then basically KGMT becomes another MT solution. So you just sign up, you have the knowledge graph creation process, and then you can utilize it in Crowden, in this case, in the cat environment, and then people can go in there just like usual, and then you would just receive the KGMT version of the target translation in the target segments. So it just gets delivered just like any other machine translation.
Right. So we need to keep moving because we have so many interesting things to talk about. Do you want to
Yeah.
say a little anything else about KGMT at this point? Otherwise, we'll jump to NLQS, Prasad.
Yeah, I mean, KGMT is quite operational, and it's delivering value. It is automated. It's available in this crowd in TMS, and so as you rightly said, there are others that are in the pipeline for us to integrate.
Awesome. So what is this other product then that we now sell, which is through our partnership? So we're talking about NLQS. What is that, Prasad?
Right. As the name suggests, it is the natural language query. So against querying what, right? It's querying both structured data as well as unstructured data. Unstructured, we have talked about all this content, right? All this text, media, images, videos, and all of that. That is unstructured, so to speak, right? And so that is one source of knowledge that you can search for. And the other side of it is structured, storage, which is like SQL databases, which are Oracle and Microsoft SQL Server, and on and on. There are like SAP, the big behemoth in the enterprise world. So they all hold structured data, and so to be able to access those databases, you would have to learn very esoteric languages like SQL, structured query language. I mean, these are like, you need a degree in its own to understand those things. Either you learn those, query languages, or have some vendor create a interface application, business intelligence applications on top of these databases. And so for routine queries that will give you your operational information for you to kind of make the next move in a day-to-day of your business, you would have to depend on these things. Either SQL, these esoteric languages, or depend on very custom created applications, business intelligence applications. And that's a big business out there. It's been there forever. But now with the advent of all these, LLMs and the knowledge graphs, so we are able to give natural language interface to any data source. So you don't have to learn that SQL or the esoteric languages or depend on these custom applications. You just use your typical Google search bar style interface. You type in your natural language against the data source, and it fetches the data back in the way that you would expect. And so it's no longer, IT is not your bottleneck anymore. Anybody, business users, experts, can directly have access to the important data in the organization.
So if I have an SQL database as a company, like what is the process to get this installed?
So natural language query server, NLQS, is a shrink wrap product that it runs in your own firewall, within your own network, because your data, you don't want it to go into the cloud or some vendor's network. uh, and then to configure connecting to your database is almost a no-brainer. It's just pointing to where the servers are, and it will know to understand what is the schema and organization of the database. And then it creates the so-called lexical layer that allows for the natural language to kind of interface to the or map to the underlying structures that are required by the database. So that is all. It's a very easy process to kind of get it commissioned in any client environment.
Right. Okay. Well, maybe that's enough about NLQS, unless anyone is specifically interested in that. Just feel free to drop in any questions or anything else. But let's go to the question that we received earlier, because we're just gonna answer some questions at this stage. I do have some other questions here also, but the first one is, where can translators train in knowledge graphs?
Okay, so one is, Edwin, you would be we are teaching at some places, right? and I have taught at a different place. And so there are other sources of learning about knowledge graphs, and particularly linguists and such. Um, I think, I can't remember the name of the institute that you were working with.
Translastars.
Okay, yeah,
We'll do a name
right.
drop here they'll be happy about that. Translastars is offering a course, and both Prasad and I are actually in that course. Most people, I'm sure, will be familiar with that group and the course that they're offering there. But they do that, and then Prasad and I have also chatted about maybe possibly offering a class to help translators upskill in human curation, the creation process of knowledge graphs. So that it's definitely an option. So if you're interested in that, please let us know, because if there's enough people interested, then we can probably put together a package and offer that in a cohort of some sort. So let us know. Okay, so we definitely have some interest, apparently, according to the chat here. So thank you for that interest. If you want to learn more about this, obviously, you've come to the right doorstep here. So maybe you can. So in the time remaining, what are some of the common misconceptions about knowledge graphs?
Yes, I'm so glad you brought it up. I mean, one of the biggest things, and I kind of mentioned in passing, knowledge graphs, first of all, are a pretty rigorous, rooted in rigorous technology stack, and it is backed by industry standard called W3C, Worldwide Web Consortium. And so it's rooted in wonderful theory, and academia and all of that has been pursuing it for a number of decades, 40 years maybe. I mean, I could be wrong, but it's long enough. And it has proven wonderful, value add to any organization, enterprise. But it has always been that the technologies involved were pretty hard to gain expertise at. You needed people to understand the so-called semantic technology, and then knowledge representation, and then understand a lot of those intricacies upfront to be able to do that. And so it used to be that finding the right skills was hard, and then of course added to that, it is expensive, and the tooling was hard to find, it was not as mainstream as possible, that you would expect. Only in the last 5-6 years, things have started changing, especially when generative AI showed up on the scene. Knowledge graph creation, which is the heart of all of what we are talking about, has become a lot more accessible. Where people and skills were required to create that knowledge graphs, they are now deploying LLMs to do that in bits and pieces. Of course, to orchestrate that, it still requires a little bit of an expertise, and that's where people that have dealt with it are better ones to go to begin with. So that hard lack of skill and all of that is to a big part kind of is done away with, and the cost itself has come down because of that. And now the knowledge is and the documentation, being that it is standardized, it's all available for folks to kind of get into it. And so it's a lot more receptive, and now the occasion has surfaced such that just the generative AI alone is as good as it is creative and it generates all the output, but you don't know every output you would have to verify. And so it almost it kills the prospect of all the value that you're looking for. Whereas you put a layer of knowledge graphs on top of that, and they are in turn your proxy. They are standing in for your knowledge, with which you are actually validating the outputs of generative AI. So in that sense, so you have deployed someone on your behalf that you trust to say, okay, now validate, the outputs of this LLM. And so now it's a better, hand in glove activity right now. That is how you can really leverage the, value of generative AI by using knowledge graphs. And so the volume of interest has grown quite a bit, and so the costs have naturally come down.
Yeah, so the Gartner also the graph shows that in 2 years, knowledge graphs will be quite something, but we're already there, so we can already help with that immediately, and which is a major opportunity for companies, also for language service providers to provide this knowledge graph creation as a service. They can offer it to their clients as to create this single source of truth. So it is definitely a value add for language service providers and consultants who might be working with clients, that require a good setup to ground all of their AI applications and AI use cases in deterministic knowledge. It's not like it's more deterministic by far to have a knowledge graph ground the large language model is just really powerful to combine that unbelievably powerful technology of large language models with grounding that as an anchor with a knowledge graph. Well, then we're combining two really powerful things.
And one the big buzz about LLM agents, agentic workflows and things like that. The best workflows with LLM agents is with knowledge graphs, and so that really opens up the prospects for the automation and the in an organization with together with knowledge graphs and LLMs. That may be one of the big use cases down the pike that we see.
Yeah, and I've already mentioned TMS, but we're also working very closely with, or we will be even more closely with Blackbird, because Blackbird that's also another opportunity to utilize that tool in order to have knowledge graph mediated translations on there, and then we can also really play with the knowledge graph and utilize that. As a source of truth for all kinds of use cases. So it's really there's a lot of opportunities for sure. So maybe a very simple question, just as we're getting to the end here. So what's the difference between a graph and a knowledge graph?
Yeah. Well, I mean, you're asking very technical question towards the end. So graph is connected, nodes, so nodes and edges make up the graph. Of course, that is the visual manifestation or even, mental manifestation of a knowledge graph also. Just that, these nodes and edges are concepts of knowledge. And when we say knowledge, knowledge is its relevance is, even though you may be interested in one narrow area of a subject matter, you want these concepts to be standing on their own right, independent of the context. So knowledge is universal, if you will, right? Knowledge itself is universal, even though you may be looking at one part of the knowledge at any given time. That part is interconnected with other concepts elsewhere. And without the notion of knowledge, and knowledge itself, that's the representation. So there are hierarchy of concepts, there are hierarchies of relationships, so in a regular graph you don't see that. You see the instances and how they are, the realities that we see, the car, the road, the traffic light, and those kinds of things. But a car is a moving vehicle, or a motor vehicle. Motor vehicle is a motor and a vehicle, and things like that. All those are conceptual underpinnings that kind of organize our understanding of what it means to be a car, or what when you look at a car. All that hidden stuff is organizing it so that moving vehicle and moving and motor and all of those things can be connected to aspects of other subject areas.
Yeah.
And so now all kinds of integration. That's how life is. So knowledge is that. So there are technologies that only focus on just producing directly the graphs, and they are good for current application. Of course, knowledge graphs are graphs for that particular subject area at the time you're looking at. but these can be integrated naturally with the rest of other graphs that come about in the knowledge graph world. Versus regular graphs will limit you. Again, you will have to think about and all of that. So all the benefits of natural integration, that understanding that kind of drives you to kind of draw big decisions across large volumes of content will be lost. You're siloed again. So that is the idea. That's the difference. I mean, I don't want to go any more deeper than that.
No, that's wonderful. Yeah, so if anyone has any more questions, just drop it in the chat, or feel free to. I think you might be able to raise your hand even if you wanted to. I could call you up, but yeah. Otherwise, just chat it. Otherwise, just to conclude, at the end here, it kind of flew by, and we actually kept just about everyone. Although I'm not sure. How actively everybody's listening as it goes with these webinars, but I'm sure that everybody's very interested, because it's such an interesting topic, and it's so powerful. And again, it grounds the knowledge graphs. They ground the large language models in this more deterministic knowledge, and it really increases the quality of the output, not just for machine translation, but also for other use cases like open search. We've mentioned that. You can do content generation. You can, and there's many other ones that we can talk about. But there's also then in the first place, we can help you with knowledge graph creation with the text still, and then because of that, we can power knowledge graph mediated translation in your TMS. And then we are able to also provide a tool called NLQS, Natural Language Query Search, if you have an SQL database. And we're just happy to help, and hopefully we can actually set up one of those cohorts to educate, more, and also about for translators to upskill to the skills that are necessary to assist with this process, because in theory, as it takes off, more folks will be necessary to help out with the curation aspect. You can, it's very interesting work, actually. I've done some of it myself, and it's really interesting to think about, okay, so what does this mean? Like, what is this sentence meant to mean? Like, not just the words, which of course is actually very similar and related and associated with the work that translators do. They don't just look at words, obviously. We're looking at meaning, right? The meaning. What is it? What is the meaning of this sentence? And yeah, so you feel free to reach out. There are the website is langoptima.com. If you're interested in further conversations about this, you can also feel free to set a meeting with me. Also, you can see my Calendly in the chat. And this recording will also go to YouTube on the LangOptima YouTube channel. And then I just want to thank everybody for attending and sticking with us on this relatively technical subject, but super interesting. And we tried to make it as simple as we could. Prasad, do you want to say some final words? Oh, there's one more question that came in. Are there examples? Yeah, so I think you may have come in a little bit later in the webinar there, but I'm certainly happy to share some of those examples that we shared earlier in the webinar later also. So Prasad?
Yeah, thank you so much. Edwin, as you said, the time literally flew by. This is a big subject area, but very relevant, very timely. It can make participation in this game pretty exciting, and and it pays off. Especially now that the tooling and all these things are available to get nearly semi-automated creating these knowledge graphs, and then and folks can be involved for their subject matter and the exciting part that they really stand for, in terms of as humans that come to delivering this computation and all that. So it's
Wonderful.
a pretty nice time. Yeah.
Excellent. Yes, absolutely. We're very excited. So again, thank you for everyone. We'll see you next time.
Thank you. Thank you all.